This is a wax type thermostat. It's basically a valve that opens and closes to allow coolant to flow to the radiator to be cooled depending on its temperature. So initially it will be closed and coolant from the engine will not be up to operating temperature, so it won't allow the coolant to flow. So it will just recirculate around the engine. It can go to the header tank, which is a reservoir, and there's also a bypass valve, so some coolant can circulate around this, so the temperature, the valve can sense the temperature. You can see it can flow through there. When it's open, it then flows through the radiator back round to the engine, and it can circulate, keeping it at temperature. So you can see that it won't flow through there because it's not open. Now this is meant to open at 88 degrees, so we're just going to test that out. Okay, we've got over 90 degrees there. So this originally came off because it was leaking, but it's also not opening. It might have opened if I could actually get the temperature of the water hot enough. So this is the coolant coming from the engine, and then it comes out the top here, going towards the top of the radiator. And inside here we've got the valve. So that bottom disc there is the secondary disc valve, and as the primary valve opens, allowing coolant to flow to the radiator, it will push that secondary disc valve, which closes the bypass. So then coolant just flows between the engine and the radiator. So that just goes in there like that. So I've just cut open this valve, just so we can see inside. You can see the return spring here, which closes the valve back up when the wax is cooled, and the inner part there you can see the piston, which sits in a rubber diaphragm, and when the wax expands it presses against that rubber diaphragm and it forces that piston out. That in turn compresses the return spring and opens the primary valve, allowing coolant to flow to the radiator, and at the same time closes the bypass valve. So you can just see the wax on the side of that capsule there that's dried, and that when heated will melt, and that is what then acts on that rubber diaphragm and forces that piston out the top. So I've got it sped up here. I'm just heating it up with a lighter just so you can see the wax actually melting, and then obviously that will expand and force the piston out. Now you might have noticed inside your coolant system there is corrosion. That's despite using the correct coolant mixture, and that is because of electrolysis. So when a current passes through a solution, that causes a chemical reaction, producing gas, but also causing corrosion to the terminals. And this is what's happening in your car. Components on your engine are connected to battery positive and are then connected to battery negative through the actual engine, passing through the coolant. This can happen either because the coolant has lost its anti-corrosion additives, in which case it needs to be changed, or because of bad earth connections on the vehicle. So you can see here, if we place our positive multimeter lead in on the battery positive and our negative into the coolant, we will get battery voltage, which shows you the coolant is actually part of the earth connection. So a bad earth connection will mean a higher resistance and therefore higher voltage on the ground side. A higher voltage will therefore cause electrolysis and corrosion. Testing from battery negative to the coolant, you won't want to see anything excessively past 0.2 volts. While we're here, we can also test the earth connection from the engine to battery negative. Again, we don't want to see anything more than 0.2 volts on a negative line. On positive lines you can have a higher volt drop of 0.5 volts.